All right, guys, welcome back. Welcome to part 2 of the video. Actually, I want to make sure that you understood how a foam works with a B fuel and an A fuel. So with an A fuel, like sometimes we'll use a foam on like a hoarder fire, right? So somebody's got a bunch of stuff in there, or a trash container, where it's just hard to dig in there and move all this stuff around. And what it does is it gives us that ability to penetrate our fuel a little bit better. Cool? Cool. All right. The dry ice is still making sounds over here.
Oh.
All right. Specific gravity. And then quit. This one's always fun. I know you guys understand this, but I wanted to show you how all of this works. Because a lot of times I get students that are just bedazzled by this. And so this was one of the terms that I kind of struggled up front to understand. So I need you, I've done this a couple times, but help keep me on track with directions. Okay, so instead of a mason jar, we are filling up this cup a third of the way with water, right? So we're right in there, all right? So now, we have green food coloring. Let's actually put this on here, so we don't get food coloring on the table, okay? Should be enough. Water soluble, yes? Okay. All right, so now, if I remember right, we add an acetone. Okay, so what's that going to do? Should float? Okay. I can put it off to the side, that way it gives it every opportunity. What'd you say? Mix?
Yeah.
Float? Okay. Would you agree, Tony? I didn't set the timer. Yeah? All right. Trying to, what term? Miscible? Solubility? Okay. If I remember right, next is the Cascade dishwashing soap. So what's this going to do? Sink or float? Huh?
That's weird.
Yeah. Lid. Sinker?
Yeah.
So does that have a specific gravity of greater than or less than 1? So then what's going to happen with vegetable oil? Huh?
That was really cool.
Stir it up as much as I can. And it separates out every time. Questions? you're gonna like this one too. I always use the colored nail polish remover so I can see how much of what I put in. So this is my flash chamber. Let me get some of this other stuff out of the way. This is my flash chamber. Now we're going to talk about upper and lower explosive limits. So what are those? Anybody?
It's temperature range.
Temperature range?
It's more concentration.
More of a concentration?
So it's got to be too rich or too lean. So your upper explosive limit, it's got to be within that range to actually be explosive. So if it's too lean, it won't burn. If it's too rich, it won't burn, right?
Yeah. So right in there, I needed to dial in my board a little bit. But right in here, when we hit that vapor pressure, it's going to that's our flash point is at the bottom of that, right? Then we get to right here, and that's our fire point. Do you guys agree with that? And that's our upper and lower explosive limit. So we get above this, and then we're too saturated, and we can't sustain that fire. Okay? So, safety glasses. And so this is my little flash container. I've used it probably 30 times. And what we do is I like to use colored nail polish remover, colored acetone, just because that way I can see exactly how much I put in there. So I need to get some more. Get this out of the way. So all I'm going to do is put a couple drops in here. And then, why isn't it flashing? Right, so then what if I do this? As we record, I'm hesitant to put too much acetone in. There it is, so, right?
Yeah.
And so all we needed was to create those vapors.
Yes.
And we needed to take it from that lower flash point to right at that happy place. And so what we did was we took it right in between here. We took it above the flash point, and we didn't quite make it to the fire point. What happened was we ran out of fuel. Would you agree?
Yes.
And that was it. Yeah, and then I don't have anything else. I mean, it's really that simple for upper and lower. And so then if we go back to this, and I didn't quite put enough water in this to make it work, but these things are all related, right? So if we didn't have this and we still had an ignition source, we could have that bloody. And that's what we're scared of, right? And hopefully we can recognize that as we're pulling up or before we leave the station. So that's why we talk about upper and lower flash points. Cool? Let's see, pH paper. You guys will like this one. What do we know about pH? Actually, the paramedics in the room probably understand pH better than I do. So maybe you guys could.
It's how acidic or basic something is. So your midpoint is 7.0, which is neutral.
Okay. So what is blood?
7.357.
So why is it a little bit basic? It is basic, right?
Yes.
Yeah. Why is it a little bit basic? I'm just trying to understand the body a little bit.
Can you show engine 7 in round 25 for Cameron Lee or Theo check?
That's just where it likes to be?
So if it was totally neutral, you couldn't have any of this. Like, if it was totally neutral, you couldn't have any, none of the systems would work, because it would always be in balance with each other.
Yeah, like I said, I'm still trying to understand pH a little bit myself. So I have pH strips. I have, anybody built a volcano when they were a kid? No? Come on, Ashley.
They don't have science education for that.
All right. Got too much stuff. All right. So then, Cap, what happens when we go to a battery spill or some sort of an acid spill on the side of the road? What's your trigger points? What are you thinking about? Not to put you on the spot, but what are
There's some solutions, is that what you're asking me? Or what?
Yeah, yeah. What's starting to go through your head? If there's an acid on the side of the road, I mean, other than environmental concerns.
So as far as mitigating it?
Yeah, yeah.
Yeah, you can dilute it, or you can take a base like your baking soda and you can try to bring the pH up. So it's less acidic.
Exactly. Exactly. So that's all we're doing is neutralizing it, right? And that's all you're doing when you're making a volcano when you're 10. It's the same thing. And so if there's acid on the side of the road, which this is just vinegar, I guess we should take a look at vinegar. Vinegar's at a 3. Okay. Okay. And then we have pH strips. What are the pH strips going to tell us? Hopefully. Oh, have you ever used one? Okay, perfect. So it has to be in the liquid. I think there's some out there that you can get close. But for the sake of time, we're going to put it in the liquid. And then they turn colors that's not even on here quite yet. So this is for a pool, and that's why. It's because you don't want your pool down to a 3, right? Okay.
That explains.
So we'll leave that right there. Okay, so then, what can we do about it? And how are we going to neutralize it? With a base.
Well, you also gotta figure out the right amount.
So how do you know the right amount?
I don't. That's-
And so I've been on this call before, and that's exactly what happened, is,
Immediately up there.
right, but you go in incremental, measurable steps. Would you agree? Again, I'm not the only hazmat tech in the room, and so if you guys have been on this call before, and I know you've been on a soda ash fire, and so it's like, I want to learn from these experiences that you've had. All right, so we're on the side of the highway, we've got some acid spill. So what we're gonna do now is we're gonna take that base, and what was this? I think it's about,
9.
yeah, 9.
So we're there, it's not quite as of a base as the acid.
Exactly. And so what are we gonna do? We're just gonna dump a little bit on this, and what's gonna happen? It's gonna foam up, and what's that doing? It's just neutralizing it. So this is what happened when you built a volcano when you were a kid. You built that volcano, you put baking soda in there, and then you dump some vinegar down it, with some red food coloring, of course, and then it all comes down, and it looks like ooey gooey awesome lava. Yeah? So now we got it to this point, and what we're doing is, as we're cleaning up, as we're mitigating this incident, we continue to use our pH strips, and we continue to just try to get a feel for where it's at. And then as soon as we get it to right around that 7, and we still have a long ways to go here, as soon as we get it close to that 7, it's not a threat to our environment anymore. Do you guys agree? All right, cool. Any questions about pH? Flammable solids. What's anybody know about flammable solids?
They make me harder to extinguish.
So, Tony, if you pull up and you're driving, say for instance you're not medicing, you're driving, you pull up and you see green fire. What's going on in your head?
My first thought is potential of chemical.
A chemical?
Alcohol. You know, is it a treated
Okay.
wood?
You see that? Is it a treated anything? Could it be a chemical? Could it be a flammable solid? And so how do you think you're gonna put that out? I mean, innocently, does anybody have anything?
Either copious amounts of water or add a foam application.
Okay. At first glance, and so I've been on this one a couple times also, and I know you have too. I'm curious to know what your experiences are like. My experiences have always been dirt. I just grab a shovel and throw dirt on it. I did run on one up by the tunnel once. I didn't realize that it was a flammable solid. I sprayed water on it and it came right back at me. Thankfully, it didn't burn any of my gear or anything. Obviously, if you make it that mad, don't keep doing it.
Magnesium.
And it must have been some sort of magnesium in the transmission or something like that.
Yeah, that makes sense.
And so we backed off instantly, started to throw some dirt on it. It went out in no time. It was just smothered it, yep. So that was all we did. All right. So what happens? So you guys know what this stuff is? I maybe should have gave you some for your coffee this morning, but I've lit this on fire so many times. It's just coffee creamer is all it is, right? All right, so we don't want very much of it. But if I try and light it on fire, just like that, will it light? Why not?
Too much of it.
Surface to mass ratio.
Surface to mass ratio. So then, if I stand up and try to change the surface to mass ratio, then what happens?
Smaller particle.
So why did that happen? Is it because I'm a wizard?
Maybe that the whole time.
I know you have been thinking that the whole time.
You just make smaller particles, so more surface area.
So it requires less energy to ignite.
Exactly, so it requires less energy to ignite. So what I did was I took the Rubik's Cube and opened it up, and so that way there was more surface area to allow more air in. Okay? Any questions about that? What else do we got? I think we're getting there. We're getting there, guys. All right. Reactivity, you're gonna like this. Can you blow these up? So what is reactivity? And I will be the first to admit that I'm still trying to understand this one also. I've spent a couple days trying to get a handle on this. So what is reactivity? Oh no.
A reaction.
There. Reactive. So when something's radioactive, what is it?
It's higher on.
No, please.
It's emitting of
Decaying, isn't it?
I think so. It's a source of energy that's actively decaying and giving off that energy.
That's my understanding of it.
Right? And so then, what are the different levels?
It's the size of the particle.
That would be
Right.
significant.
So if it's the size of the particle, is it fair to say that that is an alpha ray?
It's the size. Yes.
Okay? So it can't go through your skin,
Right. Okay.
right?
So, yeah.
Doesn't hurt, and it can't travel very far.
Okay.
Would you agree? So then what's beta?
So it is a little smaller.
Okay?
So you can go through your skin.
And it might hurt a little bit, right? So then what's, I had to, I'm sorry. So then what's gamma?
You have a BB gun over there, or what are you doing?
So I did not bring a BB gun, but my analogy is always the 30-06,
Yeah.
is that high-powered rifle that goes straight through you. And I could have adjusted this down a little bit, but there's a lead shield right here. So this is our beta, right? It goes, in this case, they say it can go through your hand and it stops at aluminum. Gamma stops with lead. Fair?
Yes.
So, and I always ask this, and I've asked this a couple times and gotten a lot of different responses, but what kind of radiation are we gonna see as first responders?
All of them.
Potentially or common?
All the above. So we are right outside of Loveland Pass. What's going past our front doors? Probably on a daily basis.
Oh, the big gamma hauler. I don't know if it's called a ton trailer or.
I think it is called
but
a ton
it's-
trailer.
It's that big missile shaped.
And so they're in these big intermodal
Yes.
packaging things. Radioactive gas?
Cast.
Cast, yep. And so they say they're pretty bulletproof. I've never been on that call, so I don't know, but I hope I can recognize it from a distance.
You,
Perfect,
plus,
good.
plus the military will tell us to go away.
I know that we have a lot of radioactive waste coming across Loveland Pass, headed towards Utah. And I'm sure there's all sorts of smaller stuff on smaller scales coming through here as well, would be my guess. Any other questions? I mean, it's just a measure of strength, I think is the best way to understand it. And again, I'm still understanding what radiation is kind of myself. So if you guys have anything to add, please do. Oh, also, anything over 88 on the periodic table is radioactive. I thought that was fascinating. I had no, I did not know that.
That's pretty cool. Yeah.
Anyway. What kind of questions do you guys have?
We took a photo of my house.
Did you like that?
That's my kitchen.
That's your kitchen?
Yeah.
This is your fire alarm?
Wait.
Yeah.
Oh.
I've been using that for years.
You've been using that for years?
Yeah.
I thought it was awesome.
Decorating
That's
style
really
solutions.
awesome.
And I know this wallpaper looks awesome in your house. I would love to come see that.
That Michelle likes that.
But she-
That's her.
As long as she's happy, there's
I'm
really
not
nothing
allowed
else
to
that matters. Yeah, so some of the pictures were plagiarized from IFSA. I do have to admit to that. They did the best job of representing what I wanted to show. Any questions about what we had going on?
I liked all of your props. That makes it a lot easier instead of just standing up there like we experienced in our earlier classes.
So I think you and
That
I
were painful.
went through that same hazmat class together.
Yes.
And so I walked away with this many flashcards that I didn't understand the meanings to. And this is how I got to this, is because once the tides were turned and I was passing this on to the next generation, I'm like, I gotta find a better way to teach you about some of this stuff. And so this is how I got here.
Because those are ops, not really trying to dig on the instructor, was painful.
Yeah,
It was just boring. It was, I don't even think we had PowerPoints. I don't recall that, but it was tough to get a good understanding.
well, hopefully this helped.
Yeah.
Yeah?
Sure,
Yeah, I like the process.
Good stuff?
Yeah.
All right.
Yes.
Thank you for considering me for a hazmat instructor.
Yeah.